Okay, then now we'll move on to the system that Arthur was telling you about. So it's a basically custom-made DRP system for UPB purposes, and it covers a lot of areas. But basically, it's a system that starts from the sales process and covers all the process through the guarantee of the project when it's finished. So all the assembly, planning, delivery, planning, manufacturing, planning, etc. It's all covered here in the system. And I'll show you it's in Latvian because not all of the system is translated, so it would be even more confusing if parts of it is in English and parts of it is not. But what the whole process is about is a project, and we have a list of active projects. For example, I'll take the one that I know that currently started. We have one project in Sweden, and the idea of the system is that we have many sub-projects, and those sub-projects basically identifies what kind of product will be manufactured. So as Arthur told, the system is not just for glass structures, glaze structures, but it's also for prefab, steel, etc. So what we have done is that we have created a structure where basically the system could support many kind of products being manufactured. So we have a glaze structure project where we have a sub-project which is named ILE group, where we know that, okay, these are the glaze structures. And the first thing that happens when the project is started basically is that designers doing their designing work upload information in the system. And what they are uploading is the elements and the parts of the elements that need to be manufactured, supplied, purchased, whatever. So what we can see is that what we do is we divide the whole project in many areas or different groups, so it would be easier to manage it within some parts. And then within those parts we have actual elements that must be built. So they could be elements, stick facades, windows, doors, whatever basically. And here we have like a rather large project where we have 637 elements to be manufactured, and I can open each and every one of it, and I can see what kind of parts must be either produced, either purchased to actually manufacture the whole element itself. And this information currently can be supported in two ways, either by Excel file, where we have this like 10,000 rows or more Excel file where we have all the elements, all the parts needed for this element to be produced. And the second one that we are working on is, as Yanis told you, that we want to sync the Tekla with our information system. So by just working in Tekla, we receive all this information instantly. And currently it's already working for prefab and steel structures that engineers work only in Tekla, and this information is just pushed into the system. And now we just will adapt Tekla to support it also for glaze structures. So the main idea is to get the information.
You mean in parts level?
Sorry?
In parts level, you mean, yeah?
In what level?
In parts.
What is parts?
No, parts.
Yeah, in part level, of course, yeah, all the detail, most detailed level that we can acquire, of course. And when this information is fed into our system, then all the responsible persons can do their work. So we can order these parts for supply managers. We can order these parts for one or either second manufacturer, because as we check all those parts, then we have some parts that will be ordered for supply managers, some parts will be ordered to glass manufacturers, and some parts will be ordered to actual this element manufacturers that will put all the parts together and ship it to the assembly. So the first thing that I'll show you slightly later is that there's a place in the system where either assembly manager or production manager does the ordering, and the second biggest thing is that each element that will be produced will be also estimated how much time it will take to manufacture this specific element, and therefore we have a estimation module where each element can be estimated, and this actual element will take 14 hours to be manufactured. And what we have done is that we have like a two-dimension matrix where these ones are the operations that must be done in factory to produce the element, and these ones are like multiple options that element can have or can have, and therefore it creates some kind of work to be done, and it all sums up in 14 hours to produce this specific element. So this is a major part where, when I'll show you how the production planner works, then one part of this production planner is to know, okay, I have many things from many projects to produce, and how much time it will take for me to produce those things. So here we have an element, we have all the parts, and we do the estimation how much time it would take for this element to be produced. So if we move back to elements, so these are the elements that will be created, and if we want to take a look at all the parts that are needed for those elements, then we can move to the detail part of the system, or not just detail. These are all the parts that are needed for something to be built. So what I have done here, I again have selected just one element. I could select like any number of elements, or like pick different rules how to select them, like one floor or something like that, and I get all the list and all the specifications that I can get from any system that feeds in the data in our system. So I have all these parts, and as you can see, then it's in Latvian, but we have order numbers. Some of those order numbers have additional number if it's supply manager's responsibility to purchase it from external supplier, and for each of those parts we have like status for substructure, like this current status is nulitava, which means it's in warehouse. I can see like, okay, it was new in 19th of January, then my hands are shaking. So on 25th it was ordered, etc. So from here I can order, and also I can see all the details. Okay, how far is exact detail, and will it be ready for me to like manufacture something or do something with it. And yeah, so one thing is that we order all the needed parts, and one more thing that we can get here is that, for example, if we have some kind of specific drawings for some of the parts, for example for glass, in this case for this specific glass we have a drawing file attached to it. So also these drawings are imported into the system, and during the ordering part, for example, I'll open like one order where we have a lot of glass parts. Some of them have drawing files where I can just click and take a look what kind of drawing is it. So, for example, in UPB's case, the glass manufacturer also works in the system, so the order is created for this manufacturer, which also works in the system. He receives this exact order, can open it and receive all the information that is needed for him to just pass the production plan or production order further. So yeah, this is the one part of the system. So we have this project-based view where all the elements, all the parts are uploaded, then they are ordered, and you can follow all the statuses that are being updated in other modules of the system. And if we take a look at these other modules, then if we take a look from the point of view of manufacturers, then it's not just one specific project that I'm dealing with, it's several projects. So the way it works is that the first major thing is that if we have all the orders, and all the orders have this manufacturing estimation time, how much time it will take to manufacture something, then to plan and to know how much time it will take for me to produce it, I need some kind of operation workload plan. Okay, how many hours per operations I can hope for, or I should plan. So we have this workload planning where for each day, for multiple shifts, for example in our case we have 2 shifts currently, we plan how many hours we have available to produce something. And using these planned hours, we can see in the graph, like, okay, what is our current workload, and system is using something that is planned actually for the next 2 weeks in this case, and compares just, okay, how much I have planned and what's the available workload. These are 100% because that process is semi-automatic, so the system just uses estimations, knows the capacities, and then just, okay, creates the plan, what could be the optimal planning. So we do the estimation, we set our capacities, and then we can use a planner to kind of estimate, okay, how much time I will spend on different kind of operations during the manufacturing process. So I can see that, okay, these 3 manufacturing operation groups take a lot of time, so maybe I should somehow switch the employees between workstations, so I could concentrate on these intensive works in these 3 workstations or work groups to support the need. And when I have set my capacities for my factory, then I have a manufacturing plan. So all the elements that are uploaded into the systems are divided in several groups. So here we have a project number. Here you can hopefully see that this is project 401, 405, 403, etc. So I have many projects and different manufacturing groups that basically usually represent one delivery to the site. So it would be easier for a manufacturer to work. They usually divide it by, okay, I have 1 truck this week or 2 trucks, and they just divide all those elements, 600 elements, into the groups that must be produced. And as you can see in this kind of calendar view, again, I have 2 shifts per day, and system plans starting from today further on, using estimated time and workloads and capacities. The way system knows what is the production sequence and what are the capacities is basically that we have production plan sequencer where we create these groups. In each group we have all the elements. These elements sum up into, for example, in this case, 226 hours. All these hours are divided in several manufacturing operations. I pick the priorities of these groups that must be manufactured, and then I just start the planning, and system just goes one by one and tries to plan as soon as it can and as efficient as it can all those elements. And the result of this planning is that again, if we are returning to the manufacturing plan, is this plan where each group has some kind of hours reserved for specific date. It's not always like specific plan, but it's a good estimation and a good starting point for actual production planning for the future. And if I want to take a look what's actually in each of those groups, then I can just open it. I can see all the elements. These elements, if I open the element, then I get to the same place that I showed you before. I'm in specific project, in specific element, and I can see like specific estimation of this element, which is 22 hours and 58 minutes. So if I move back, then if everything's okay, then we should see the same hours needed for production. And if I open again this element furthermore, then I can see, okay, I have I don't know, any 8-9 operations that must be done sequentially. So okay, on this day I will do the cutting, then it's CNC and something like that. So yeah, again, the basic idea for the plan is that we have workloads, we have estimations, and we create these manufacturing plan estimation, and then from the system we can get any kind of reports, production plans, or something that's needed to pass on to the factory, so factory workers would know what to do, in which order, how much time they kind of estimated, they are estimated to need to do the specific operation. Sorry? No, it's completely different in Latin. Yeah, actually now also, of course. And of course the next part is that that I won't show to you, but basically from this, as we have something estimated and we know later on which workers worked on that day, which is also like entered in the system. So if this is the plan, then we get this pop-up where we can say, okay, on this date I did some specific operation, and not just operation, but I can also say which person did the operation. So yeah, so I can see that this specific element, the cutting was done by this person, this team, and they did it 100% of the job, because you can do something partially and then someone continues to do something. So if I have the information, okay, what was the estimation, what was the nauda that you could get for doing some work, and later on, if I know that, okay, these persons worked on that day, or this person did the specific job, I can calculate salaries automatically to know, okay, these are like the salaries that you should get, and of course there is always some kind of adjustments that could be done, but all the calculations are done in this system, and then they are transferred to accounting system.
And of course, it's quality insurance. It's like traceability. You can trace if there is something wrong, who was responsible.
Yeah, of course. I won't go into details because it might be boring. There is also quality assurance part of the system where if something gets defected or something like that, then you create a claim against productions, or you do it against the engineer, specific engineer. And we have all the analytics later on to see, okay, how many claims we had this year compared to between previous years and do some like serious analytics. Okay, what goes wrong? How often? What are the improvements? Or maybe there are no improvements, etc.
Just one injury.
Sorry?
Maybe just one injury.
Yeah, always one, yeah.
Yeah.
There's some.
Yeah, and of course, also the thing is that if I have estimation, okay, you should do something within 1 hour, and then when they log in their work and they have spent 2 hours, then gathering it all up within a month, you can see, okay, what is the coefficient of each worker, where he is most productive, or maybe he is just like always doing something slower than he kind of supposed to do, and etc. Again, it's like there are a lot of data that is in the system, and you can analyze it however you want, but the more you enter into the system, the more you can get out of it. So. Yeah, this was the basic process, that this upload, manufacturing plan, and the status updates, and our now the biggest.
How's the entering actual operation when it's done?
When it's done, it's in this window. So, for example, if I want to enter only cutting, then I check. Okay, I want to enter only cutting information for all the elements in this group, and then I just press.
Do you have workstation in the workshop or computer in the workshop?
How it's done?
Yeah.
Actually, I think usually it's done at the end of the shift by a manager, because workers are working and they're just like writing down, then they give their sheets of paper to the manager.
In the precast factory, we scanned progress after each operation. We can deploy it here as well, and so on. The same as goes for the warehouse and so on.
Yeah, for precast manufacturing, it is a little bit more simple, because it's one huge element, and then you can just always, you know what to beep, and then you just press, okay, I did that, but in case of like element or something like that, there are many parts, so okay, I cut this, so where are they? So slight changes, but
too many things to
Yeah,
it's not too many, but it's something.
Where you put the tags, when the screw or a box of screw, and when is the element formed is when you cut the profile or further down the line. So it's lots of decisions. So it's just.
Also, it gives very good feedback back to engineers, because, for example, your unit facade consists of something 600 profiles, and you see in the system, for example, how many of them are already cut. For example, out of your 600 profiles, 300 are cut, and you see exactly for which are cut. And if the architect sends you that he wants some changes, you can quickly see if the changes can be implemented, or it's too late. We have already cut the profiles, and we can. And if in case it's okay, you can quickly change the model, and the system will move those profiles so that you see which profiles need to be cut.
What about to utilize existing profiles in your warehouse? Are you manipulating with your warehouse?
No, we don't have any spare profiles. We order to specific project. And,
It will be in near future. Our next step is currently we are doing optimization. For example, from Chukal, the Chukal tells we need to order 100 profiles. Factory orders 105 profiles because they will break something. But they will still have extra profiles. And our next step is that for factory it's very important space that we will link when the profile needs to be cut, when the element will be assembled. And the system will in the future will optimize that ideal optimization will be 100 profiles, but if you cut something on the first day, you might need some part of this cut at the end of the project. But and so it will lay in the factory for 2 months. It will get lost. Something will happen to it. And so our next step is that ideal optimization is 100 profiles, but maybe with 105 profiles, there won't be this wait list. That you cut something and it will be used within 2 weeks, not within 2 months.
What I'm doing right now is that I thought that I could show how all the parts are like ordered and gathered up in deliveries to projects. So I'll just leave two. So what we have here is like a deliverable list. So for the project, that there are two main sources of things that must be transferred to construction sites. Some things are uploaded by engineer that, okay, you need these things to finish the project. But there are some things that are just supply stuff that site manager just orders, okay, I need gloves, drills, or whatever transferred to the construction site. So we have this additional list, okay, deliverable list, that everything that you ordered to supply manager and everything that is uploaded by engineers. And if I have if I have this list, then I see all the things that must be delivered either to the object, or it could be also delivered to the factory. And for this we have this like one variable, or either it's objects. Objects means construction site, and sex it means factory. And then we are creating these packages. And if I open it up, then I can see what kind of elements is in the package. And I can also see that all these packages are in one actual delivery, and this is a delivery. Oh, it was one package? Oh yeah, no. Oh, there are two numbers, yeah. I missed it. There are actually two deliveries. So we have two deliveries where I have something from supply managers. I don't know what is Purana, but it's something useful, I guess. And we have actual elements, and those several packages are combined in one delivery, where we have a ready add date, which is at 10 o'clock, and then there is like the planned delivery day. Which is strangely, I guess this won't be on time. But we have this one document. They add some kind of documentation and pictures also as attachments to this delivery. They can get transportation documents from the systems right away. So in this case, this is CMR document where we have all the information, where should we pick up, and there should be also a truck that will pick up the delivery. And this information is entered in the logistics module of the same system. So everything is kind of linked together. As Arthur told, if we enter one information once, then everything uses it, and it comes together in reports or any kind of documents that are generated by the system.
For example, in heavy construction, the site manager can tell exact times when he needs exact elements delivered, and so the
Crane.
So the crane is able to operate smoothly. That the element is delivered right when you want to assemble it. So you just take it from the truck and you put it already on the site where you want it to be assembled.
Oh. And last thing is that what is the goal, and we are on finishing steps of this goal. I'll show how it looks in a prefab, and it should look the same in glazed structures also. That we have built the functionality in the system that we have created a 3D module which is basically imported by IFC file from the Tekla, but it also works like from any program that can generate this type of the file, and it's a common format right now for this, but we have some kind of element types. We can see where we have like specific type of details or specific elements. We can see just for example first, second or third floor, and if currently the model is colored by like type of elements, then I can switch and see, okay, I want to see this element by element status. The element status in this case will be all violet because it's all assembled, but then again if I want to see project progress, then I can again switch the mode, and then I have like from to date where I can see the project progress. So if I go backwards, I can see that, okay, this dark green is manufactured, then light blue is delivered, so I can see, okay.
On the exact moment, it's like status.
Yeah, it's status on this date, on 25th of May, until this floor, everything looks like it's installed.
In the status information from all the business units doing their work. Basically, if element is in the production plan, shows one color. If it's the production workshop drawings ready, another. If it's in a port already for shipment, another. And it's this is as illustrates the goal of the system, that you get information from everywhere, everyone doing their work, and put it together so it's available for everybody again, so they can spot some sort of delays in the project, some patterns they need to address, and so on. Like we are developing this in say it's moving along with capabilities of browsers, because this is for precast, and initially we developed this functionality some 2 years ago, and the browsers by then were very slow, and it could barely turn this model. Now the browsers are starting to utilize like OpenGL standards, like learning to use your computer hardware is getting much faster. But for Glaze systems, if we upload a full Tekla model, again, it's pretty slow, but in half a year, when the technology advances, we're going to be able to see every single screw and then statuses and so on. So it's you always like move along with technology, and the same as with our system and Tekla. We advance Tekla, advance our functionality, and see how the system works together, because we're interested in so that the key economic benefits for project execution, from sales to maintenance.
And of course, again, this is just an illustration that this system, the purpose of this system is to gather information from like everywhere and put it together. So the visual stuff and everything that's in the model, it comes from Tekla, and then if I just want to see, okay, I have the element from Tekla, I can link it to something in our system, because I have some kind of identifiers to do that, and then I can take additional information that is only in our system and put it all together, and I can click on the element and I can open it, and again I'm here, I can see the element, I can see some kind of information what's in it, and everything kind of works in one whole process. So. Okay, maybe some additional questions that are part of the system that I didn't show you, but
implementation, I mean, on construction side, direction plan or some gaps.
Okay, so then we have two approaches. If we use the how we plan prefab, and I'll show it to you. How we plan for prefab and steel. Then for prefab and steel, the installation and erection plan is made by each element that is in the model or is in the building. And what we did is, so basically we have a list of elements, and we plan for each day how many elements there will be, and it's pretty detailed. And we did it the first time. We did the same for glaze structures, And we understood that that's not the approach to take for glazed structures. And the issue is that you don't just take one element as it is for prefab pretty much, that okay, you take the wall, you placed it, okay, and then afterwards you polish it or do some of the work. For glazed structures, the issue was that okay, first you put in like the elements, then you have like some additional works, then additional works, and like this installation of one element actually takes like several steps. And what we progressed into is that we have works. Okay, for example here. We have like a positions with works, but it's really tied up with the way we do our budgeting. We have budget positions, and each of these positions are linked to specific elements. So basically, here we have stick facade, west, per. I won't actually know what each of these works mean.
It's like zoning.
Yeah, the positions are zoning, but each zoning is also divided in up to 4 divisions. But it's just our way how we do things. That we have for each zoning, we have like for example, these are 100. I guess these are 100 square meters that are done in one day for a specific zone. But the idea is that we don't work with each one of the elements, but we work with square meters, or whatever makes sense for you to plan and to say, okay, I have done like something. Because if you do it by each of the constructions, the problem is, okay, you don't do it just once. And the second thing is that those constructions are so much more than in prefab, so it takes like half a day just to create the plan. Then but always something changes, then you need to push. But if you plan just the square meters, you have a zones, each zone is linked to specific set of elements, and those were the deliveries they create, then they have a kind of a good feeling, okay, I have planned the work, I know that it's linked to specific delivery. I can check if delivery is fine. If delivery is fine, that means that this work is planned correctly.
So actually, the beginning is here.
The beginning is here, and also the ordering part that I showed you, that where they order, okay, glass from one manufacturer, then elements itself from another manufacturer, yeah, and then it comes together. And but at the end, of course, if we want to see the progress, okay, how far we at in assembling or erecting all the building, then assembly plan is where it all lands, where I can see. And of course, behind all this is also a budgeting part where each of those parts that I showed you before, not each, but the most important parts have the value. We calculate how much, what is the production price and what is the sales price of each. Actually, I could show you, I guess. Yeah, here, for example, in this case, for each of these elements, we have calculated what is the sales price of this specific element. The budgeting is quite specific, and it would take like additional meeting just to cover that. But we have an algorithm where we know how we can calculate price for each element, and also from some of the sub parts. For example, glass is quite valuable, and we assign those values. So we have we can create an automatic report for customs. When they ship it to the Norway, I guess they need to report something how valuable is the constructions that you import. And also we know that, okay, if we have sold like something for 1 million, then we can calculate, okay, this month I sold like these 7 or 8 elements, so my progress is 3%. and system automatically can calculate it by those deliveries. System knows in which day we delivered specific delivery, or which day we produced delivery, so we can calculate, okay, how much I have produced, how much I have delivered, and at the end, of course, I can know how much I have installed. But that's, I would say it's quite specific to UPB, but the basic idea core, of course, will be the same for everyone. The key points that, okay, I need, okay, how much I have produced, how much I have delivered, that's everything is the same for everyone, but maybe the budgeting part itself might slightly differ for different. Yeah, also, yeah. So,
what about you? Your pricing based on what?
Project to project, difficult to say in one sentence.
yeah, we also had this issue that, and also that when you sell, then it's in one way, and when you actually want to deliver the project and see what's the progress, it's like completely something else. So yeah, it was a challenge, and we think that we have now finally settled for a good solution. How this transitions from sales phase to actual budget, and how it is how it's evolving afterwards.